Hello everybody and welcome to our webinar today. And the title of today's webinar is 10 things you should know about behavior driven development, Cucumber and SpecFlow. And our presenter today is Seb Rose of ClaySnow UK. And at the end of this webinar, we'll have a Q&A session. So if you have any questions for Seb, just type them into the control field there. And at the end of the webinar, we will go through your questions one by one. And remember, you don't have to wait till the end of the webinar. You can type them at any point. So I'm now going to hand you over to Seb. Hello, Seb.
Hi.
So Seb's just going to open up his screen here now, and we'll be ready to get started. And I can see your slides.
Excellent. Okay, hello everybody. Thanks for coming along. I guess the first thing to say is that, as you might notice from this slide, although ClaySnow is my personal company that I've been working with for a number of years, I'm joining in with the Cucumber Limited company over the coming months. So you'll see me talking and I'm working with Cucumber Limited rather than with ClaySnow probably from June onwards. Also, I should probably apologise. I call this session 10 things you should know. I find it difficult to cut it down to 10, so there's definitely 11. And that's because I'd like to start by talking a little bit about the history of BDD. BDD's been around for a while now, and BDD, as Dara just said, stands for Behaviour Driven Development. It came into existence probably back in the early 2000s when Dan North was trying to teach TDD to developers. And I'm guessing that we have a lot of testers on the line here since this is Test Huddle organised, and you may be aware of some of the behaviours of developers around the world. Anyway, what Dan discovered in 2002 was that when he was trying to teach people test-driven development, they didn't really like being asked to do any testing. When he used the word test in his training, developers tended to turn off, and he found this difficult when he was trying to teach them to work in a professional way in their development. So this article that's referenced from this slide is an interesting place to start. It's where Dan starts talking about BDD, and of course it's Dan North who coined the term behavior-driven development back in the early 2000s. So he'd been working with these sort of problems, trying to work around them for a number of years, and he was over at an Agile Development Conference in the States in 2004, and on his way back he happened to sit next to Chris Matz on the plane. Some of you may be familiar with Chris, who's a business analyst also working out of London, who had been sort of struggling with similar problems, possibly not quite so development focused, but around trying to get people to talk to each other and really think about requirements rather than go through them and check them for formatting. And they discussed the use of the word should. From that, Dan North became inspired and thought, right, it really is time that I should do something about this. And what he decided that he should do is create something called JBehave. Now, this is a very technical solution to a problem, but back in those days, Java developers were working with a unit testing library called JUnit, and in that iteration of JUnit, the way JUnit decided whether something was a test, an automated test that needed to be run or not, was to look at the name of the test and see whether it included the word test. And of course, when Dan put this little piece of implementation detail together with his observations that developers don't like writing or thinking about the word test, he decided to create JBehave, which instead looked for the word should. Well, JBehave has come a long way since then, and it does many things other than just recognize the word should. And there have been a number of other tools that help join up specifications written in business language through to executable specifications. But this was how it started. Dan tried later on to try and coin, phrase a definition of what BDD was, because people often ask, what is this thing called BDD? And he came up with this definition. It's quite well, it's certainly not a succinct definition. It's one that's open to much interpretation, and to some extent it didn't really tick the boxes I think that Dan was trying to do. However, it does cover all of the bases, which is essentially that lots of people need to be involved. Automation is a great thing that comes out of it. We want to work in an agile way. And it ends by saying that it's working tested software that matters. So that's a bit of a background just to get us into the BDD space. I guess one of the things that certainly challenged me in the early days that I was working with Fitness and Cucumber were that I saw a lot of different acronyms kicking around. There was BDD, there was ATDD, Acceptance Test Driven Development, there was Specification by Example, and of course there's good old TDD. And a question that people often ask is, what's the difference between them? So this is a close-up photo of Liz Keogh, who works with Dan has worked with Dan very closely, and was actually responsible for the first release of JBehave. And she tried to address this question of what's the difference between these acronyms in an article, again referenced there at the bottom of the slide. And her answer is really very simple. She basically says that they're just called different things. All these acronyms refer to the same process, which is about trying to communicate the intent and the behavior of the software so that we can agree that we've understood the problem correctly and are proposing an appropriate solution. There's probably a bit more nuance than just saying they're all exactly the same. I think possibly TDD, as in test-driven development, is quite often focused at getting technical members of the team to communicate effectively together and document things from an implementation point of view. Whereas ATDD, BDD, and specification by example are very much about getting the technical and the non-technical team members to communicate effectively together. Liz also is very hot on the idea that tools are not the essential part of BDD. So tools such as Cucumber and SpecFlow, which are obviously referenced in the title of this presentation, are really wonderful things, as are Fit and Fitness and many of the other flavors of test automation tool that are out there. But BDD itself is not about the tooling. It's about an approach to developing software. So just to refer back to Dan's definition of what BDD is, you'll recall that he does say in this definition that high automation is part of this. It's part of the BDD process. It's one of the benefits of following a BDD approach using some of these tools. However, it's not the most important part of BDD. The most important part of BDD is ensuring that people are actually communicating effectively together, and that communication is done in such a way that when there are discrepancies between our viewpoints or understanding of the problems that are trying to be solved, we can work them out. Now, Liz is a great author. She's written a number of science fantasy books, which I encourage you to go and have a look at if you're interested in that sort of genre of literature. But her blog posts on the BDD space are really excellently well written, and so at some point go off and have a look at some of her musings over the years. And this is one of the phrases that I had really caught my attention as I was reading Liz's work over the years. And here she's very clearly communicating that the important part about BDD is having those conversations, actually speaking to people and ensuring that the communication is of a high quality, is a high bandwidth. Once you're making sure that you're speaking to the right people, that you're communicating correctly, and that there are no misunderstandings in the way that we're talking to each other, then we can start capturing those conversations, actually recording the conversation. You'll know yourself, if you have a conversation with someone you think you've all agreed on some actions, you can come back the next day and you will remember slightly different aspects of the conversation. So have the conversations, that's the most important thing. Then once you've got the right people to have those conversations with, record them, capture them in some way, and then finally, it's really powerful to automate those conversations. So take the behavior that you've described and write automated scenarios, automated tests that drive out that behavior in your software. But please don't try doing it in the other order. Many customers come to myself and Cucumber Limited and ask, from a perspective of test automation, they say, well, we would like to learn more about Cucumber because we want more automated tests. And unfortunately, coming at it from that point of view will lead you quite often to automated scripts that are fragile and brittle, hard to understand, that don't document the system. And by turning it around and saying, let's start with the conversations, begin to understand how the system should behave, that's how we get to automated tests that are actually meaningful, that actually document the systems that we're trying to develop. So this is from a much earlier blog post by Liz, but essentially, again, it's her stressing the fact that we want to find out where the risks are, where the unknown assumptions are lurking, where the difficult parts of our next problem are going to surface. And she often references here a book by Marco and Lister called Waltzing with Bears. And I would strongly recommend anyone who's interested in trying to manage risk on software projects to go and have a look at that book. So the third point that I'd like to make is that collaboration is entirely essential. So I've tried to emphasize that tools are not essential. Collaboration is essential. And here we have a picture that that references the Three Amigos from the film of the same name from quite a long time ago now. It's not my favorite film, and actually it's not my favorite name for the collaboration that goes on in software development organizations, but nonetheless it has been used over the years, and I think to some extent we're stuck with it. So the Three Amigos basically says, when you want to have one of these conversations, a structured conversation where you're trying to discover how the system is supposed to work, you need to have representatives or viewpoints from at least 3 different perspectives, hence the Three Amigos. And the perspectives that we talk about are the developer, the tester, and the business. So as long as you have people representing those perspectives, you can have a full discovery discussion to try and understand the different aspects of the problem. So understand what the business want out of it, understand what technical challenges there might be, understand what might go wrong or how you may need to test it. So this is the process that's called the Three Amigos, and is documented in the books on Cucumber, written and published by the Pragmatic Programmers. And here, Aslak Herzog, the creator of Cucumber, wrote an article trying to, again, describe why collaboration is at the forefront of the vision of Cucumber itself, the Cucumber the tool. So I'll obviously let you read the words yourself, but again, what he's trying to do is make sure that we understand that the power of Cucumber is not the fact that it directly automates our conversations. The power is that it gives us a forum in which to communicate accurately with people who don't come from our discipline. And that space, that conversation, is in the books called the Three Amigos workshop or the Three Amigos meeting. We tend to call it a discovery workshop these days, because actually we don't want to limit it to 3 Amigos. We maybe want to bring extra people in, but what we do want to do is uncover and discover what the system is supposed to be doing, how we're going to deliver value to our customers. And the discovery workshop looks pretty much like this. You come to the discovery workshop and someone should have done some preparatory work. And ideally, if you're working in an agile process, that preparatory work will lead to there being some user stories. That's the typical way that we plan incremental delivery of software in the agile space. And then inside the discovery workshop, all 3 roles, or everyone there, actively contributes and challenges the understanding of this user story by coming up with concrete examples of how the system should behave. Now, when you focus on a concrete example, that gives you ideas and questions about whether you've really understood the user story as it's currently described, and it allows you to start challenging the business rules that govern or control the scope of that user story. And so you'll see the feedback loop coming out of this discovery workshop from the examples, which gives you extra ideas Now, these ideas may be refinements of the way the business rules are expressed, or it could be ideas about how to split the user story into smaller user stories, which is always a useful side effect. Coming out in the bottom right-hand corner from the discovery workshop are automated tests and code. So clearly, if you can articulate the way the system is supposed to behave using concrete examples, these concrete examples make really good test cases. Specifically, they make really good candidates to be automated as test cases. And those automated test cases in a behavior-driven or test-driven way will then enable the development team to actually develop the code in a way that directly addresses the needs of the customer. And this sort of suite of automated tests or automated scenarios make great living documentation. So what you're doing is you're documenting how the system should behave, and you then run those scenarios as tests, and if they pass, then everyone's happy because now you have a system that behaves in the way that it's documented, and if they fail, then one of two things has happened. Either a regression or defect has been introduced, or the documentation is now out of date because the system has been developed and has diverged from the way the test documented it should behave. And both of these things are really good. So first off, you'd love to catch regressions automatically, but secondly, if your documentation is becoming out of date, you'd really like to be notified of this. I'm sure you've all worked with systems where the documentation isn't exactly 100% up to date. So the discovery workshop has to fit into the process somehow. This is a very simplified overview of the Scrum process, and the discovery workshop is often slotted into the standard process as part of the product backlog refinement or backlog grooming process. So it's pre-sprint planning, and it's where you take the stories and you try and get them into a state where they're ready for the developers to pick them up. So it might be part of your definition of ready. Now, that's certainly the simplest way to slot it into the Scrum process. However, it must be said that if you're trying to prepare an iteration's worth of stories, that could end up being quite a long meeting. And I'm not a big fan of long meetings, so my preference, wherever possible, is to have many small meetings in the sprint before we're intending to start work on a particular story. And in each of those meetings, focus on one or two stories and run the discovery workshop on them. Then after the 2 to 4 weeks of the current iteration, we've got enough stories prepared, ready for next iteration. We could talk about that plenty more. Maybe there'll be some questions about that at the end. Cucumber itself is a really simple tool. And here, when I say Cucumber, I include SpecFlow, and there are other Cucumber tools in the Cucumber family, such as Behat and Behave, and many others. Cucumber doesn't do a whole heap of stuff. The core concepts are that Cucumber is driven by feature files. Now, feature files are text files. They're plain text files. There's nothing magic about them. There's no special markup. There's certainly no special contents in them. They can be edited in a standard text editor. And these feature files document the behavior of a particular feature of the software they're trying to build. A feature file is made up of a number of scenarios, and you can think of a scenario as a test case, or you could think of it as the example of a single behavior of the system. But essentially, they're a way of writing in the business language how the system is supposed to behave. And you will have multiple scenarios for any particular feature, because obviously there are multiple ways of using most features. Each scenario is made up of a number of steps, and the steps are basically it's just essentially a list of operations that are going to be taken to enact this scenario. And each step corresponds essentially to one call through to the system of some sort. The steps are written in a syntax called Gherkin, and we'll see a bit of Gherkin later, but Gherkins are a really simple syntax. It's available in many different spoken languages. See, English is the one that I'll be showing the examples in, but there are others. And it expresses the standard given, when, then approach to writing out scenarios. Developers among you might be more familiar with arrange, act, and assert, but essentially the Gherkin allows us, in using business language, using English or whatever spoken language is most suitable to our culture, to express setting up the context of how the system should be before the behavior is exercised, setting up the action that should be taken to actually focus on the system doing something for us, and then using then to talk about the assertions or the checks we should make after the action has taken place. This is all written in business language, and we are wanting it to run our applications. Somehow we need to join the business language expression of the behavior through to the system that we're trying to build, and what we use there is glue code. So it is code, but it's code that somehow joins up the specification to the application that we're building. Within the glue code, we write step definitions, and these step definitions are written in the language of our choice, depending on the flavor of Cucumber that we use. So, for instance, in Java, if you're using Cucumber for Java, in Ruby, if you're using Cucumber Ruby, or in C# if you're using SpecFlow. And these link through one step definition, essentially, for each step that you find in a feature file. And then the step definitions themselves, they are just method calls. And so within them, you just call directly into your application. You can do it at a code level by doing method calls or creating objects and issuing messages or commands to them. Or you can, in your step definition, use a library such as Selenium WebDriver, or maybe a Jersey client to package up REST calls. Essentially, Cucumber, the Cucumber barrier ends at the glue code. And within the step definitions, you can use any tool at your disposal to interact with the application that you're trying to build. And these scenarios, these steps, are an articulation of the examples that you discovered in the discovery workshop. So those given when thens are a direct mapping of examples, the concrete examples that you find in discussion with your colleagues at the discovery workshop. So here's an example feature file. And this is written in Gherkin. You'll see that it's got a few keywords in it. They're slightly colored in dark blue. Feature at the top. The feature has got a name in this case. This is a feature about scoring for a team. Then after that comes some free text, which describes, well, you can put it's free text, so you can put anything in there, but in this particular case, it's describing the rules that govern the behavior that this feature is trying to describe. And it's got two scenarios in it. One that talks about the fact that a team, when registered, should start with a score of 0, and another that says that if you register a team and start playing a game, you get a score of 10 for submitting a correct, easy answer. Hopefully you'll find this that easy to read. The thing is that the words that come after the keywords, so the text such as I register a team, that's language that's developed by you and your customers and your developers working together in collaboration. This is what's called the ubiquitous language. It's domain and team specific, certainly organization specific, and it's something that evolves and gets developed to correctly and accurately articulate what's going on in your department. Now, when you point Cucumber or SpecFlow at a feature file like this, it starts finding those step definitions mentioned in the previous slide and calling the code. And when that happens, it starts coloring these lines in to show the outcome of calling that code. So in this example, the first scenario is run, and both of those steps have passed, and so they get colored green. And that essentially is telling us that this documentation is correct, the system behaves this way. Then I'll run the second scenario, and what it shows us is that, well, it's all good up until the point of the score, and it's saying that actually we should have had a score of 10, but it didn't. Now this is a very cut down demonstration just to fit on the slide, but essentially if you were to run this in SpecFlow and Cucumber, it would then tell you what the score was or why it had failed, and you'd then be able to either, as a developer, go in and implement the correct code, or go in and debug and find out what had gone wrong. I guess the next question is, how does Cucumber know which step definitions to call based on reading the step from this feature file? And the answer is it uses regular expressions. So this is an example from Ruby, and you'll see here after the given word there's a phrase between forward slashes, and that's a regular expression. So essentially what Cucumber does is it pulls the text out of the step in the feature file, and then it goes off to the glue code and looks for a regular expression that matches and uses that to decide what code to call. The Java translation of this is somewhat more verbose, but essentially the same thing is going on. You'll see after the given annotation, there is a string which contains I register a team, and that again is treated like a regular expression. C# is similar, again slightly different syntax, but it's the same general process. So many of the Cucumber and SpecFlow style implementations or tools use regular expressions to link between our feature files and our step definitions. Cucumber and SpecFlow are not exactly the same. So they both utilize Gherkin, and they both have the same approach, but they're maintained currently, at least, by different organizations. I'm going to skip through this somewhat, but one of the main things that people notice is that Cucumber and its associated tools doesn't really pay much attention to the difference between the keywords used to introduce a step. So a given, when, and then they're all interchangeable. SpecFlow is more particular, and a given step will only match a given step definition. And so that's one of the most obvious variations. As your test suite and your application grow, you'll find you have lots of different feature files, and you'll also end up with lots of step definition files. However, sometimes you need to share data between those step definition files, and the different implementations have got different ways of doing this, and that's because the languages are very different, and the idioms for sharing data vary massively between them. There's also a technical angle to the implementation. There's something called hooks. Hooks are not, there's no visibility of hooks from the feature file. So the feature file is written in Gherkin, it's written using the business language, the ubiquitous language, and it's there to facilitate communication between technical and the non-technical team members. However, there's something that you need to do just to get the system up and running in a test environment from a technical perspective. It might be starting a web server, it might be configuring a database. There are all sorts of things that you might have to do as a developer to get a test environment ready for a scenario to run. And hooks are there to enable the developer to do that without polluting the non-technical feature file. And again, SpecFlow and Cucumber have different steps available, different hooks available at the moment, and that does lead to some discrepancy. So if we track back to the feature file and the scenarios that document the behavior, write up the examples in a way that is consumable by the business, people begin to get a bit anxious about where is this going to live, how are we going to manage this, what other documentation might we need. So I guess the first point to point out is that a feature file is something that describes how the application should behave today. It's not related directly to a story. So user stories in the agile world are vehicles by which we plan the delivery of increments or product increments to our application. And quite often, a story will start off by introducing some maybe cut down version of a piece of functionality, and then a subsequent story will refine on that understanding and implement perhaps more validation or better user interface or extra pieces of functionality, extra ways of using it. And so those stories become out of date. But the feature file, which documents the behavior of the application, should continue evolving. And so the feature file, for us, the way we work, is the definitive document that says how the application is working today. So if we go back to looking at the the example I introduced earlier to do with team scoring. So you'll see a feature file on the left, and on the right you'll see the classic set of our artifacts that get generated from the inception by the BA or the product owner all the way down through to the examples that get thrashed out at the discovery workshop. So the first thing to point out is that the examples, when you start writing the feature file, the examples get translated or modified, or mutated into scenarios. And so these scenarios document each of the examples that you came up with in the discovery workshop. So at that point, you can essentially throw away or ignore the examples because they have been captured in the feature file, which is checked in with the code. The acceptance criteria get documented as that introduction to the feature. So the acceptance criteria are about what are the rules that need to be obeyed, what is the functionality that needs to be provided for our product owner, for our customer, to be happy that the system is behaving in the way that it expects. So again, once that gets checked into written into the feature file and checked in, the acceptance criteria can go away. And then the last bit is the user story. And the user story, there's no place for it in the feature file. The user story, as I've previously described, is a vehicle for planning a product increment. So as soon as that product increment has been delivered, the user story itself can be put into the bin. So I know that you probably use TFS or Jira, and that the user stories are sitting there in the electronic backup forever. They are not needed to describe how the system works. They may be useful for traceability purposes, but essentially the feature file itself is the evolving documentation of how the system behaves. More documentation is probably necessary, so the feature file is not the only form of documentation. You probably want user manuals, you will probably want installation guides, you'll troubleshooting for your support team. So we're not trying to say that feature file is all you'll ever need, but it's a very good starting point. We also want to remember that although this is leading to a lot of automation, or at least potential automation, there's no possibility, and there's certainly no desire to the loss of test resources as a side effect of this. So we need skilled testers, not least to participate in the discovery workshop, but also there's a lot of testing that still needs to be done. So if you recall the testing pyramid, the foundation of a testing strategy from a development point of view is the unit tests at the bottom of the pyramid. But at the top, you'll see this the cloud of exploratory and manual testing. And this is where testers can truly deliver value because of their skill background and their understanding of how systems often fail to deliver the value to the customer. And the automation that BDD allows or permits, encourages, means that actually what we get is we get more time to let our testers work in an exploratory way, and that then means that we catch a different class of defect and in the end deliver better value to our customers. There's also the agile testing programs that are worth considering. Here what you see, and this was proposed by Brian Merrick and has been worked upon by Lisa Crispin and Janet Gregory over the years. And here, the automated things are on the left. These are areas where the automation from BDD can help. But there's still a lot of things that require manual and specialist work, and these are shown on the right-hand side of this quadrant. However, BDD is not just for testers. So I've been in some places where people think that because it's got tests, the idea is that we're writing scenarios that test the application, they're acceptance tests. Well, essentially, the developer doesn't need to get involved, and we can just let the test team write the scenarios and the features and automate them, and everything will be fine. So that's unfortunately, no, not unfortunately, that's just not the case. So writing automated scenarios, writing any form of test automation is in fact something that requires development skills. So although BDD encourages and requires the participation of testers and developers, it also requires development skills when it comes to doing that automation work. So if you recall the layout feature file, the glue code, and the application that I showed in an earlier slide, that was a sort of summary of what it looks like. In reality, what you often get is quite a lot of support code. And if there are developers listening here, what I'm thinking about is code that will create graphs of test data that will allow certain complex interactions with the web UI, such as through page objects to take place. It's actual real code, and to write it, you need to have an understanding of some of the coding practices. You need to understand what the constraints of code development are. And so although it's a great place for developers and testers to pair, it's not a space where I would encourage the testers who don't have development skills to work on their own. And here, we've been trying to build this ubiquitous language that expresses the behavior of the system so that testers, developers, and business people can all work together. And again, if what you do is you say, well, we'll have the discussion as testers, developers, and product owners, but later we'll just let the testers go off and write the feature file and do the automation code, then it's not a ubiquitous language that's being owned by the whole team, because the test team will build it and write it based on their perspective, and there won't be a feedback loop for developer or product owner to pitch in and say, I don't think this is the right way of phrasing it, this doesn't mean anything to me. When it comes to writing scenarios, there's a big question about how detailed do we want to get. And what we've found over the years is it's useful thinking about it from a point of view of imperative and declarative. We're looking for, we're essentially looking to write scenarios in a way where we talk about what the customer or the user of the system is trying to achieve, and that's in the declarative way, but not how they're going to do it. So not about which buttons they click on the screen, what drop downs they use from the menu, what links they follow. We want to put in enough detail so that the example, the scenario is concrete, that we can really understand what's trying to be achieved, but not so much detail that it becomes overwhelmingly difficult to understand. So, we are trying to document how the system behaves, and so from that point of view, we don't want lots of nitty-gritty details that are incidental. What we're trying to do is put in enough detail to make it concrete, but keep it at a high enough level so that it becomes documentation that's easy to read. Dan North, we come back to him again, wrote an excellent post on this topic a number of years ago, and is a post in which he says, if you're finding it hard to say quickly and concisely what's happening in this particular interaction with the system, it may be that you haven't identified a domain abstraction, that there's another way of describing it, but you've reverted to talking about clicking links and pressing buttons because you haven't yet, as a team, discovered a way of describing it in a declarative way. So, moving swiftly on, very little that's worthwhile in life is easy the first time. So I'd like to introduce you to a website called Cyber Dojo. And in Cyber Dojo, it's an online development environment created by a colleague of mine called John Jagger for teams to practice test-driven development. And over the past couple of years, we've enhanced it to also allow us to practice using Cucumber and SpecFlow. So here's an example. You can see here a list of languages. Cyber Dojo supports many, many languages. And C# supports SpecFlow. Java supports Cucumber, as does Ruby. And what this allows us to do is, as a team, practice using some of these tools in a safe place, not on development worktops, not on workstations if you don't want to, and you can do it at home, on the bus, in the bath. You don't need to install anything. And if you go and have a look at CyberDojo, you also see that it facilitates working as a team. So you can have multiple pairs or groups of people working on the same problem and then compare how different groups arrived at a solution. It's a very powerful training tool, and I really think that if you want to practice BDD using Cucumber or SpecFlow, it's a great place to start. So this is my time to do a quick pitch. I'm involved in producing a conference called XP 2016, which is the world's longest running Agile conference. It's taking place in Edinburgh at the end of May. And you'll see scrolling along the screen beneath the logo, some of the great people that we've got coming to present there. There's also open space and lightning talks as well, so everyone gets a chance to get involved. If you've got a taste to pick up some tips about exploratory testing from Elizabeth Hendrickson, or speak to any of the other great names that are going to be there, I really recommend you take it, have a look at it, and come along. So to wrap up, here are 10 base 2 things that you should know. So boiling it down to just 2. First off, BDD, it demands collaboration. It's not a test automation approach. It's not about taking one role and giving them extra responsibilities and excluding other people. It's about collaborating. And finally, the examples are at the core of BDD. The concrete examples mean that when we are discussing things, we have something for us all to agree on and understand right down to the core. And because of that, they facilitate that feedback loop, which allows people with different perspectives and different viewpoints to work together to deliver the software that the customers need. So thank you very much for listening, and I'll hand back to Dara.
Thank you very much, Seb. I'm just going to open up my screen here again, and I'll open up my slides now. You should all see them very shortly. So there we are. We have another webinar on tomorrow with Jeffrey Payne, and this is on continuous everything. It'll look at Agile and DevOps, and for more information on this, just go to the Test Huddle site there, and you'll see all the information there. Over on the EuroSTAR side as well, you can find out about our pre-launch discount code, 20% off. So if you go to the EuroSTAR conference site there, you'll see a link that will tell you a little bit more about this discount. Also on EuroSTAR, you can find out about a one-day testing event that we have coming up in April. It's called the EuroSTAR Roadshow 2016. And this will be taking place in Warsaw on the 27th. And we have a number of different presenters there. We've got John Foda, we've got Ruth Tunis and Rob Lambert giving keynotes. You can also hear from Alexandra Kasapu, Declan O'Riordan. We've got sessions in Polish with Radosław Smilgan and Michael Strajak. And don't think I'm leaving anyone out there, but if you want to find out a bit more about this event and how you can register, just visit the EuroSTAR website and click on the link. And finally, let's have a look at some of the questions you have coming in. Okay, and the first question I have here for you, Seb, says, how do you get the developers to the table to have the conversation with an open mind?
Well, so it's a great question, and the answer is the same whether you're trying to get the tester there with an open mind or whether you're trying to get the BA or product owner there with an open mind. But it comes down to the fact that we're all trying to get software out to deliver customer value, to make sure that the customer is getting the software that they need, and we're not having to do rework after we ship because we've misunderstood something, delivered something that's not supposed to be there. So to some extent, in the work that I've done with customers, I've not had an issue with getting developers to the table. What the developer wants to do is to be able to compute and control the understanding of the technical constraints of the domain, and it's a great forum at which they can really show their chops. Same goes for testers, same goes for product owners. it's a place where everyone's viewpoint is valued. And my experience of working with people in the industry over the past 30 years is that it's when you value people's input, when you value people's opinion, that they really start to give you strong and valuable input.
Okay, before I move on to my next question as well, I forgot to mention that Dorothy Graham is another speaker at our roadshow event, so apologies Dorothy for not mentioning your name there. The next question for you, Seb, here is asking, if a keyword-driven automated test fails, who discovers that, who acts on it, and what does that person do?
Okay, so there's lots of different questions in there. So the first is you state keyword driven, and I guess we're thinking robot framework or something like that. And this is a similar way of working. Cucumber is not so much keyword driven, but it's ubiquitous language driven. But then to dive into the actual question, the first thing that should be happening is that these scenarios or acceptance tests should be executed from the developer desktop. So if you can picture the test-driven development cycle, which is red, green, refactor, it's a loop where the developer starts by writing a failing test, then gets the test to pass, and then refactors the test, the code, until it looks it's as good as they think it needs to be, all the while keeping the tests green. That loop is a development loop where the developer will be working essentially in isolation or in their pair. But you can think of a larger or wider, more encompassing loop, the acceptance test or the behavior-driven specification loop, where you start by writing a failing scenario. And that failing scenario should be runnable from a developer desktop. The developer then dives into their TDD loop, writing code, writing unit tests, refactoring to make things look better. And when they think they've implemented the code that would satisfy that acceptance test that they started off with, they then run the acceptance test again, and it should now be passing. So this is where the acceptance test first passes on the developer desktop. They would then check it into the source control, where it gets picked up by the continuous integration pipeline, one would hope. And at that point, it should still be passing. If it's not, then there's obviously some issue to do with the integration or the configuration in other CI environments, and the developer again needs to ensure that that gets fixed. Once you've got the CI pipeline green with that acceptance test, with that scenario, then it should, one would hope, stay green. Clearly, sometimes things go wrong, and when that goes wrong, the acceptance test will fail. And as anyone who's been practicing CI for a while knows, the most important thing, the most important responsibility of a development team is to ensure that the build stays green at all times. So when a regression or a failure happens, that gets signaled in the CI dashboard. One would hope that your CI tool is set up to notify all team members that the build is broken, that your information radiator on the wall goes red, or the siren hoots or flashes, or whatever you've got set up, and at that point the whole team comes together and says, who's going to fix this? How are we going to sort this out and get the build green? Because nobody can do any work and check in any extra code until the build is green again. So I guess to sum up, it's at different stages of the life cycle of a scenario of an acceptance test. Different people have a primary responsibility for making sure that it's green and fixing it, but in truth, once it's been checked in and it's acting there as living documentation of how the system behaves, when it deviates, when it breaks, when you get an error, it's then the responsibility of the team to identify who's most best placed to fix it and to get it going, get the build green as quickly as possible. And that might mean taking that test out of the build, possibly permanently if it now documents behavior that's been removed or has changed, or maybe taking it out temporarily while you diagnose what the problem is.
The next question in front of me here asks, do you see any particular problems in implementing BDD on a database solution? So the biggest problem I've had at client sites with implementing on a database solution
is more organizational than inherent with BDD. So quite often, because of the nature of, well, the history of many of the larger organizations I've worked with, the database is owned and managed by a group of people who are often not involved directly with the development teams. And so that introduces handovers, blockers, and just generally hurts the communication between the development team and the database itself. If you can get over that, then I would say that I haven't seen any real issues. So I would tend to here be thinking about the smaller, more nimble companies that use databases, who will often be using some form of scriptable evolution of the database. They'll be using liquid-based or something like that to manage the development evolution of their schema. And so then it becomes, you know, quite a natural extension of the development process to be able to write tests that hit the database and ensure that the schema is evolving in a manageable way.
And sorry, I just closed my panel here momentarily by mistake. I have it open again now. And the next question is asking, do you use a continuous integration approach for BDD tests? And if yes, what kind of tools?
So yes is the answer, and you can use any of the continuous integration tools. So you know, the cruise control or Jenkins or TFS, they will all plug in. So Cucumber and SpecFlow both link naturally to the native unit testing frameworks that run on their platforms. So there are bindings between Cucumber and JUnit. There are bindings between Cucumber and RSpec. There are bindings between SpecFlow and XUnit and NUnit and MSTest. So essentially, it's just like running your unit tests in the continuous integration pipeline. The CI pipeline itself doesn't need to know that it's dealing with a inverted commas BDD tool rather than just its standard unit testing tool.
And the next question is asking, is BDD really used for only web services or end user facing services? Would you use it for integrations with APIs or backend databases?
Yeah, no, absolutely. BDD is not only used for dealing with web services or end user services. BDD is about being able to express the behavior of a system, and it's totally agnostic about what implementation the system has or what interface is being surfaced. So for instance, if you went in and started playing around with Cucumber or SpecFlow using the CyberDojo tool that I was development environment that I showed during my session, you would develop essentially unit tests using Gherkin written in the business language. And that's a really great skill to practice. Essentially, BDD is about describing behavior using examples. And you can use that at any point. It can be as low level as a method where you think about examples of what sort of flavors of parameters might be passed in and what sort of return values or exceptions might be thrown in response to that. And then you can build out, you can think about how components are going to behave, what their API is. You can go straight out to REST services where you could be passing in packages of JSON, or you could be driving a website using Selenium. But I would recommend you consider at all times the agile testing pyramid that I showed, and remember that what we want from a team perspective, what we want is lots and lots of small, fast, reliable tests at the bottom of the pyramid, and far fewer large end-to-end tests that drive the whole system at the top. And this is an area where there's lively debate and has been lively debate over the past few years. So you will find people who disagree strongly with me. You'll find very persuasive people that disagree strongly with me. However, I still haven't seen a large enterprise scale system with a suite of end-to-end tests that are maintainable and give fast feedback. But I've seen plenty that have a balanced suite of tests which is based on fast, reliable unit tests and a few end-to-end tests to make sure that the system builds and deploys correctly that are very nimble, very agile, and robust to changes in requirements.
The next question here is might be a bit long, so I'll repeat it if you need me to. It's asking, how would you approach manual test case creation documentation when user stories acceptance criteria are in Gherkin format from the business? How would you use the acceptance criteria?
Okay, so I mean, let's unpick this one ever so slightly. First thing is that, as far as I'm concerned, the Gherkin given when then, they're defining examples, not acceptance criteria. So the rules are much more general than an example. And that's one of the things, if you get a chance to do a Google search for an article written by my colleague Matt Wynn called Introducing Example Mapping. And if you read that, it's just a short article, you'll understand our perspective. So the user stories have acceptance criteria, which are the business rules that govern the scope of that story. And the examples illustrate and explore those acceptance criteria. Essentially, a rule is quite a general way of expressing a constraint on a system, and an example is one particular set of data or context that illustrates how that rule behaves. And so you'll have multiple examples that illustrate any given rule, probably. So we've got, first off, so that's first thing. So please don't express acceptance criteria in given when then format. Try and find an abstract declarative way of saying what the rule is. Second question is, how did you then translate that into manual tests? And I guess I would push back with a question saying, why are we trying to do that? If you do need to do it as manual tests, then the examples that are given to illustrate those acceptance criteria are simply just instructions. When you do it using Cucumber or SpecFlow, those instructions are to the step definition that then compiles the interactions with the underlying application. If you're going to do it manual tests, then you would write that out in longhand as instructions to the manual tester. It feels to me like you're missing an opportunity if that's what you're trying to do.
Okay, we've gone over the hour now, so I might just take one more question, Seb, if that's okay.
Okay.
The question here is asking, what are the downsides of BDD? Is there anything it doesn't do well that you should consider?
Yeah, so there are some downsides to BDD. The first is that it will really expose organizational issues about who's responsible for particular parts of the infrastructure, who's prepared to collaborate in a free and equal way. And I would suggest, certainly in my experience, that's been the major challenge, trying to ensure that that we can unblock this way of working, allow people to communicate freely, and allow people ownership over the stack so that a team can truly develop an end-to-end solution. There are some sort of processes that make it harder to work in a BDD way. So I would say that organizations that have, even if the organization itself is amenable to working in a collaborative way, a lot of legacy application stacks make it very hard to write automated tests anywhere except for at the end-to-end level. And that leads to all sorts of problems. So the fact that you have to test something from end-to-end means that you've got to spin up the whole of the application stack to run one of these scenarios. It means that it's very hard getting reliable data sets that will address particular test cases. You end up with very brittle, very expensive test suites to maintain. And I think that is an area where it's not even just BDD that's an issue. Any form of test automation, and if I could go probably further to say any form of testing at all, becomes expensive and painful because the environments haven't been created with testing in mind.
Okay, we'll leave it at that for today, and thank you very much, Seb, for that webinar. It was brilliant. We had people from all over the world tuning in, and there's lots and lots of questions. So thank you to our attendees as well for coming along and for all your questions. A recording of this webinar will be available on Test Huddle shortly. And over on Test Huddle too, you can see what other webinars we have coming up over the next number of months. So that's it from us here today, and take care, everybody.
Thank you.